Hey there. Tonight, we're heading straight into the cosmic fog that hides the most secretive place in our galaxy, the center of the Milky Way. You're about to drift through a city of stars so dense, so luminous, and so ancient that our familiar night sky seems like a quiet rural village by comparison. You're going to see where gravity itself becomes an artist, sculpting light, dust, and time into a single living canvas. And you probably won't survive this, well, not physically, but it's fine. You're only here in imagination, wrapped in your blanket, probably halfway between curiosity and sleep. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And tell me in the comments where you're watching from and what time it is in your corner of the universe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift beyond the solar system's comforting glow. The Milky Way's arms curve around you like ghostly highways of starlight. Each passing light year brings more stars, tighter packed, until the familiar pattern of constellations dissolves into a swirling fog of radiance. Ahead lies the galactic bulger region so thick with stars that darkness itself seems exiled. It's not an empty black void, but a golden storm, its light muted by curtains of interstellar dust. From Earth, we never truly see the center of the Milky Way. Our view is blocked by 25,000 light-years of smoke-like dust and molecular clouds. It's like trying to stare through 1,000 layers of fog while someone keeps dimming the flashlight. But radio telescopes and infrared eyes, like the James Webb Space Telescope, can pierce that obscurity. They reveal what visible light cannot: a shimmering, crowded core where millions of suns jostle for space within a few light years. Imagine the sky there so bright. Night never really falls. You hover now amid that glowing chaos, surrounded by thousands of stars that could fry your retinas if you had real eyes. Their light isn't the soft sparkle of a midnight sky. It's a constant, blinding sea of fire. And between those suns drift lanes of soot-vast tendrils of carbon and silicate grains twisting through gravity's pull. The dust glows faintly under ultraviolet light, turning the galactic heart into something like an endless ember. Scientists call this zone the Central Molecular Zone, a name that sounds oddly bureaucratic for something so majestic. Here, enormous clouds of hydrogen and carbon monoxide swirl around the center, forming the raw material for future stars. It's a galactic recycling plant, where stellar death feeds stellar birth. But the balance is delicate shockwaves from ancient supernovas, and the black hole's gravitational tides rip and fold these clouds into fantastic, chaotic shapes. Some regions collapse into new suns. Others are shredded before they can even begin. You drift closer, feeling that faint tug, the same pull that governs the entire Milky Way. It's gravity's subtle persuasion, a whisper that every star obeys. Even your imaginary feet feel lighter here, not because gravity is weak, but because everything's moving with it. The galaxy's stars, dust, and dark matter all orbit one unseen axis. And at that axis, something waits, but not yet. First, you notice how crowded the neighborhood is. Within a single cubic light year, there might be 1,000,000 times more stars than around our Sunday. If you lived here, your night sky would never go dark. You'd read by starlight, though honestly, the radiation would kill you faster than you could finish a paragraph. Here's a quirky fact. Despite being a region bursting with light and energy, much of the galactic center's dust is only a few dozen degrees above absolute zero. Cold, dark pockets float between infernos, like icebergs drifting through lava. Scientists still argue whether this strange temperature mix is due to magnetic shielding or the complex dance of turbulent gas. Either way, it's a place where cold and hot coexist in uneasy truce. You glide through one such region, now a dusky corridor, where the light fades into a faint orange glow. Electrons skip between atoms, releasing whispers of radio waves. Instruments on Earth detect these whispers as faint, rhythmic pulses. The sounds of the center. Not music, not exactly, but a kind of galactic murmur that tells astronomers what's happening beyond sight. Your ears ring faintly as if you can almost hear it. The hiss of hydrogen, the sigh of cosmic rays, the deep rumble of magnetic storms. It's peaceful, in a dangerous way, like the calm inside a thundercloud. You can sense the invisible energy flowing around you, sculpting paths for gas and light to follow. The Milky Way is alive, breathing in millennia, exhaling new stars with every cycle. And even here, in this celestial crowd, there's mystery. Some regions seem to glow more brightly than expected, as though something is heating the dust from within. But no star is visible there. Some astronomers suggest it could be rogue black holes, tiny wandering ones, quietly devouring matter in the shadows. Others think it's dark matter, interacting faintly with ordinary particles, releasing ghostly light as a side effect. No one's sure. Scientists still argue whether we're seeing the leftovers of past explosions or the subtle signatures of physics we don't yet understand. You keep floating. Ahead, a ribbon of gas curls in slow motion, glowing faintly red and blue, where radiation ionizes it. It's called the Arches Cluster, one of the most massive known in the galaxy. Thousands of young, hot stars burn together here, their winds colliding to carve out cavities in the surrounding dust. The sight is hypnotic, almost painterly. Turbulent waves of energy, curling like smoke in zero gravity. And beneath it all, the faint hum of motion continues. Stars orbit the unseen center, each one tracing an elliptical path like beads on an invisible string. The galaxy spins, and the core holds steady, an anchor of gravity older than memory. You can almost feel it now, the faint, persistent gravity of Sagittarius A asterisk, the black hole that waits deeper inside. Every atom in this vast city of stars obeys its silent command. But for now, you're still among the outskirts of the core, hovering in the dusty, glittering twilight, surrounded by a billion suns, drifting slowly toward the heart of everything. You drift farther into the brightness until you can no longer tell whether your eyes are open or closed. There is no such thing as night here. The light never truly fades. It just changes color, like the galaxy's mood lighting. If Earth's sky is a calm suburban night, the galactic center is Times Square turned up to 11, surrounded by ultraviolet glare and X-ray flickers that would cook any unshielded planet. Day and night, those are Earth words. Out here, the rhythm of darkness and dawn dissolves. You could orbit one of these stars and still never see a sunset, only a permanent, simmering glow bleeding through the dust. The Milky Way's center doesn't sleep. It pulses, hums, and burns. And as you move closer, that hum becomes a chorus of invisible radiation. Imagine being on a planet near this core. You'd see tens of thousands of suns hanging in every direction, glowing amber, white, and blue. The nearest star might be as close as our solar system's outer edge, just a handful of light months away. Shadows would be faint, overlapping from every angle. You wouldn't need a flashlight, or even a sun. The whole sky is your sun. But of course, you wouldn't last long. Your planet's atmosphere would fry, your oceans would boil, and the magnetic fields that protect Earth from cosmic tantrums would crumble. It's a neighborhood with a beautiful view, but absolutely terrible living conditions, like buying a penthouse above an active volcano because the sunset looks nice. Still, the idea of such constant light feels strangely comforting, doesn't it? Like the galaxy itself refuses to let you drift too far into darkness. Maybe that's why so many civilizations in myth place their gods or ancestors in the sky's bright center, the axis mundi, the place where light and eternity meet. The truth, though, is a little less poetic. The core's brilliance comes from extreme density. In just a few light years, there's as much mass as the entire disk of stars you see stretching across the Milky Way from Earth. Astronomers estimate more than 10 million stars crowd this small region, many of them giants dozens of times more massive than our Sunday. And they're not gentle neighbors, they roar. Stellar winds crash into each other at millions of kilometers per hour, creating shock waves that ripple through the dusty medium like waves through smoke. You drift through one of those waves now, the heat pressing against your imaginary skin. The temperature jumps suddenly from near absolute zero in the cold dust lanes to several million degrees in the glowing plasma streams. Every particle vibrates with energy, releasing radiation that instruments on Earth detect as X-rays. The Chandra X-ray Observatory once captured these bursts, mapping them into haunting blue arcs. They resemble lightning frozen in space. But here's the strange part. Despite all this chaos, stars still manage to form. You'd think the heat and turbulence would tear everything apart, but somehow gravity keeps pulling gas into dense knots that ignite into new suns. Scientists still argue whether this star formation happens in bursts triggered by collisions of giant gas clouds, or whether it's a steady, ongoing process fed by the black hole's magnetic fields. There's even something weirdly rebellious about these young stars. They're called stars, and they orbit the black hole in tight, unpredictable paths. But before we get there, notice how they seem to glitter differently from the rest: blue, white, electric, restless. They were born in defiance of impossible conditions, in a region where gravity and radiation should have prevented birth entirely. Some researchers half-jokingly call them the punk rock stars of the Milky Way. They shouldn't exist, and yet here they are, living fast, dying young, leaving supernovae as cosmic graffiti across the center's dark walls. You float past one of these rebellious suns, a massive blue-white sphere shedding streams of gas into the void. Its stellar wind collides with another's, forming a shimmering bow shock like the wake of a boat cutting through water. That shock glows faintly red, marking the boundary where one star's chaos ends and another's begins. You realize that out here, borders are made of plasma, not politics. Everything negotiates through gravity and heat. Stars push and pull, collide and merge, erasing individuality over billions of years. There's something oddly humbling about it, a drifting observer, watching creation and destruction happen so fast, it's almost rhythmic, a mainstream fact to anchor you. The Milky Way's center lies about 26,000 light-years from Earth, in the direction of the constellation Sagittarius. From our vantage point, it's hidden behind thick clouds of dust and gas that block visible light. That's why it wasn't until the mid-20th century that astronomers realized there was something extraordinary there. Something more than just a dense cluster of stars. But humans being humans, we didn't stop at something. We built arrays, interferometers, and orbiting telescopes to probe deeper. We began to see hints of orbits that made no sense, of stars moving far too quickly to be bound by visible matter. Something invisible was pulling them, something huge. But that revelation comes soon. For now, you're just soaking in the perpetual daylight, floating between giant suns that flare and fade, their light bouncing through curtains of cosmic dust. A fun, quirky tidbit before you drift onward. There's a type of cosmic dust molecule found in the galactic center that smells well, not to us directly, but based on its chemistry, like raspberries and rum. It's called ethyl formate. So technically, the heart of our galaxy smells like a dessert bar. Astronomers discovered it while studying the Sagittarius B2 molecular cloud. Makes you wonder if the universe is teasing us, leaving little jokes scattered across billions of light-years. Still, the humor fades as you realize how violent this beauty is. A single supernova here could outshine the entire galaxy for weeks. The shockwave from one dying star can ignite thousands of new ones, turning the core into a rolling cascade of energy. Yet even that destructive grandeur follows rules, gravity's rules. And the closer you get to those rules' ultimate enforcer, the more the light begins to twist. Photons bend, distances warp. The perpetual day starts to distort like a reflection on rippling water. You can feel the galaxy's heartbeat growing stronger now, a gravitational pulse calling you inward, deeper, toward something so massive that space itself kneels before it. Night never truly ends here, because time itself starts to lose meaning. You drift closer still, and the stars ahead begin to move faster, like dancers caught in an unseen whirlpool. At the center of it all, something waits, patient, invisible, impossibly powerful. You take a slow breath, floating closer to the galactic heart, where light forgets how to escape. You drift through the storm of light and gas until it begins to bend, to swirl, to curve inward around something unseen. The brightness you've been surrounded by starts to smear like wet paint, tugged by invisible hands. You're nearing the core of gravity's empire, the place astronomers call Sagittarius A*, the supermassive black hole at the center of the Milky Way. It's not much to look at directly because, well, it's invisible. A black sphere of silence about 4 million times the mass of our Sun, wrapped in a glowing cocoon of plasma and starlight. But its presence warps everything nearby. Light curves, time stretches, space ripples like fabric being pulled too tight. You float there, close enough to feel its pull, but not so close that you tumble into eternity. It's the perfect vantage point, like standing on the edge of a cliff and looking down at infinity yawning beneath your feet. Scientists figured out Sagittarius A*'s existence the same way you'd figure out There's a monster under a rugby, watching everything above it move strangely. For decades, astronomers tracked the orbits of stars racing around a dark spot. These stars weren't meandering lazily, they were slingshotting at thousands of kilometers per second, whipping around something that emitted no visible light. Only one explanation fit: an incredibly massive, incredibly compact object. The discovery was confirmed beyond doubt in 2022, when the Event Horizon Telescope collaboration produced the first image of Sagittarius A*. Not the black hole itself, but its glowing halo, the light of gas heated to billions of degrees as it spirals into oblivion. That blurry golden ring became humanity's first portrait of our own galaxy's heart. It looked like an eye made of fire, half shadowed, half glowing, staring back at us from across the void. You hover now just outside the event horizon, the boundary where gravity's grip becomes absolute. From here, time dilates. 1 minute for you might be years for someone far away. The starlight around you blurs into streaks as the photons bend and twist, unable to choose a straight path. You reach out figuratively and imagine dipping your hand into the flow of space-time itself. It feels viscous, elastic, strangely alive. Every particle here is caught in a dance between freedom and fate, deciding whether to escape or fall forever. Some make it out as radiation, others spiral inward until even their information, what they once were, seems lost. But maybe not forever, because here's one of the open debates that keeps physicists up at night. Does information truly disappear inside a black hole? Stephen Hawking once thought so, then changed his mind, then changed it again. Scientists still argue whether the event horizon erases reality or just hides it in quantum code we can't yet decipher. Maybe everything that falls in gets smeared across the black hole's surface like a hologram. Maybe nothing's ever lost, just reorganized in ways we can't yet imagine. It's strange, thinking that even black holes might have memories. Cosmic elephants with gravity trunks. The area around Sagittarius A times is a paradox factory. For example, right now, you're surrounded by gas that's moving at nearly the speed of light. This gas forms an accretion disk, an enormous whirlpool of superheated matter swirling toward the event horizon. The friction inside that disk is so intense that it glows across the electromagnetic spectrum, from radio waves to X-rays. If your eyes could see all wavelengths, this place would look like a kaleidoscope of lethal beauty. Every color, every flash, every vibration of energy colliding in chaos. And yet, Sagittarius A times is considered quiet. Compared to black holes in other galaxies, ours is practically meditative. Some galaxies host active nuclei that blast out jets of radiation, stretching millions of light years into space. But the Milky Way's center? It snores. Occasionally it burps a sudden flare, a puff of X-rays, but nothing catastrophic. Scientists think it's underfed, not getting enough gas and dust to stay active. Imagine a celestial beast on a strict diet, nibbling at the edges of the galactic buffet but never feasting. Still, the potential energy here is unimaginable. If Sagittarius A times were to consume a massive cloud or a star, it could flare so brightly that even people on Earth would notice the night sky briefly changing. The Event Horizon Telescope team once observed a sudden flicker, an hour-long brightening, believed to be a clump of gas spiraling inward, glowing hotter as it died. You drift just above that glowing maelstrom now. The noise here isn't sound, but if it were, it would be the deep rumble of 1,000 storms overlapping a subsonic growl that shakes the very fabric of your imagination. Every so often, a burst of light shoots upward, where magnetic fields tangle and reconnect, forming what physicists call coronal loops. These arcs of energy can fling matter into space at relativistic speeds, tiny messy jets that hint at the black hole's restless hunger, a mainstream fact to keep you grounded. Sagittarius A times sits about 26,000 light-years away, and its event horizon would fit comfortably inside Mercury's orbit. That's the scale we're talking about, something smaller than our solar system, but containing millions of solar masses. It's like stuffing all the mountains, oceans, and planets you've ever known into a single cosmic marble and then telling gravity to have fun. Here's a quirky tidbit. Despite being so massive, Sagittarius A times has the density of air if you could somehow spread its mass evenly across its event horizon. Gravity's weird like that. Mass and density play by rules that our human brains refuse to find intuitive. You can almost sense it breathing now, if breathing is the right word. Every flicker of radiation, every pulse of plasma feels like a heartbeat. The black hole inhales gas, exhales light, and the galaxy around it shivers in response. Some scientists poetically describe the Milky Way as a self-regulating organism, with Sagittarius A times as its central nervous system. But others always argue, that we're anthropomorphizing it, making nature too human. Maybe the center doesn't think or feel or regulate. Maybe it just is, following equations written long before consciousness appeared. Still, floating here, it's hard not to sense intention in that symmetry, in that rhythmic draw and release. You gaze into the darkness, and the darkness gazes back, bending your reflection into infinity. Somewhere within that event horizon, the laws of physics collapse. Time stops being a line and becomes a whirlpool. Space folds in on itself until all directions lead inward, and yet you remain, hovering at the edge, where the rules still make some sense, where the universe whispers instead of screams. Behind you, stars race by, their orbits tracing luminous ribbons through curved space. Ahead of you, the horizon glows gold and red. You're between two infinities, the ordered and the unknowable. You could stay here forever, suspended in gravity's cradle, watching the galaxy spin around you like a hypnotic mobile above a cosmic crib. And maybe that's exactly what the Milky Way has been doing all along, rocking itself gently around this invisible heart, keeping time with the silent pulse of Sagittarius A asterisk. You drift closer to the swirl of gravity, where light curves like smoke rings and stars behave like reckless dancers. At first, it looks chaotic, tiny points of light whizzing in every direction, blinking in and out as they disappear behind walls of dust. But the longer you watch, the more you realize there's a pattern. Every orbit, every flicker, every streak is part of an elegant, invisible choreography. You're watching stars waltz with a black hole. These are the stars, the ones that gave Sagittarius A times away to us. They're young, shockingly young, given where they live. Their orbits loop tightly around the center, some whipping past at speeds over 7,000 kilometers per second. Imagine traveling from Earth to the Moon in less than a minute. That's how fast these little cosmic daredevils move. One of them's too is the celebrity of the bunch. Astronomers have been watching it since the 1990 seconds, tracking its path like a celestial heartbeat. Every 16 years, it swoops in close to the black hole, coming within just 17 light hours of the event horizon. That's about 3 times the distance between Pluto and the Sun. But on a galactic scale, it's practically brushing the monster's cheek. When S2 swings by, its speed peaks, and space-time itself warps visibly. The starlight stretches into red and then blue again as it swings away, proof that Einstein was right. You can see it now in your mind's eye. A tiny, blue-white star, cutting through space like a spark off a welder's arc. Its path tracing an elegant ellipse through warped geometry. Behind it, light from other stars bends, twisting into delicate rings called Einstein arcs. The scene feels both violent and graceful, like ballet performed at gunpoint, and there's something eerie about their youth. These stars shouldn't exist here. The gravitational tides around Sagittarius A times are so strong that gas clouds shouldn't be able to collapse into new stars. The black hole's gravity should shred them before they can form. Scientists still argue whether these stars were born here in defiance of the odds, or if they migrated inward from farther out. One theory suggests they formed as a star cluster farther from the center and slowly spiraled in, losing momentum until gravity caught and reshaped their orbits. Another theory, more rebellious, says the black hole itself might have acted like a cosmic matchmaker, capturing stray stars from the galactic disk and forcing them into these elegant loops. You drift between them now, watching streaks of light pass like fireflies at supersonic speed. Their trails fade almost instantly, leaving after images in your mind. Each orbit is a clock, ticking not in seconds, but in centuries. The galaxy measures its heartbeat in their paths. You notice something strange. The stars don't just move in perfect ellipses. Their orbits precess, that is. They shift slightly with each loop. It's not Newton's clean geometry. It's Einstein's curved space at work. The black hole's immense gravity drags space-time itself, twisting it around like a spoon stirring honey. Each orbit leaves a subtle ripple in reality. When scientists measured S2's precession in 2020, it confirmed general relativity with stunning precision. Gravity, it seems, has a flair for performance art. It's mesmerizing, but not peaceful. Radiation crackles invisibly through the void. The nearer stars occasionally flare, shedding gas as they skim too close to the beast's gravitational claws. Some are swallowed entirely, an act known as tidal disruption. When that happens, the star's light erupts one last time, brighter than anything else in the galaxy for a few days, as its material spirals inward and vanishes. You'd think of it as a star's final scream, echoing across space before silence resumes. But in this dreamlike journey, you're not a victim of the violence. You're a silent guest, watching from within the calm between collisions. You float toward a faintly glowing riband, an arc of gas stripped from one unlucky star. It glimmers like silk caught in a spotlight. The glow shifts from orange to turquoise as it cools, swirling lazily toward the event horizon. For a brief moment, it looks almost peaceful. Then it fades, gone forever. A mainstream fact to keep you grounded. The orbits of these stars allowed astronomers to measure the black hole's mass directly. By tracking their motion, They calculated that Sagittarius A times weighs roughly 4 million suns. That's how we know what sits at the center. It's not speculation, not theory, but motion, measured and confirmed, over and over again. But the quirky side of this is the black hole's sense of humor, or at least the universe's. Each time we point our instruments at it, it changes a little. Sometimes it flares, sometimes it dims. One night it's calm, the next it's spitting X-rays like a cosmic cat hacking up photons. Astronomers joke that Sagittarius A times has moods. Maybe it's camera shy. Maybe it just doesn't like to be predictable. As you watch S2 streak by, you realize the black hole isn't the only player in this dance. There's the gravitational field of nearby stars, magnetic flux lines, turbulence from incoming gas streams, all tugging at each other like threads in a tangled web. You could spend a lifetime here and never see the same pattern twice. And still, amid all this motion, there's silence. No air, no sound, only the faint flicker of energy and the whisper of curved light. It feels sacred, in a way. A cathedral of gravity. Its pews made of orbiting suns. Its hymns sung in radiation. Then, something catches your attention. A ripple at the edge of your vision. A faint shimmer, almost like a heat mirage. A star? No. A black dot moving behind the stars, bending their light but showing nothing itself. It's a clue to another mystery, a swarm of hidden companions that may haunt this place. But that's for later. For now, your gaze drifts back to the waltz, the looping, glowing arcs of starlight, carving invisible geometry into space-time. The stars spin and flare, each one a fleeting spark in a dance that will outlast human civilization by millions of years. They circle endlessly, bound by beauty and terror, performing their gravity ballet for anyone patient enough to watch. And somewhere, inside that swirling choreography, the black hole waits, humming a lullaby only the universe can hear. You drift even closer to the gravitational ballet, but this time your attention is caught not by the dancers, the stars, but by the empty spaces between them. Here, faint threads of gas twist like ribbons caught in a solar breeze, drifting lazily yet held taut by invisible tension. They shimmer faintly in infrared light, glowing with the signature of carbon monoxide and hydrogen molecules that shouldn't be here, not this close to the black hole's blazing energy. These are the G-clouds, enormous, ghost-like blobs of gas and dust drifting within light days of Sagittarius A*. They look fragile, ethereal like cosmic jellyfish made of fog, but they're tougher than they appear. For years, astronomers watched one of them, G2, as it fell toward the black hole, expecting a spectacular death. They predicted it would be torn apart, its gas shredded and flung outward in a bright, fiery arc. The universe loves drama, after all. But when the moment came, nothing. G2 sailed past Sagittarius A*, barely must. It stretched a little, yes, but didn't disintegrate. No burst, no explosion, just a quiet, defiant glide through the galaxy's most dangerous neighborhood. Scientists were baffled. Some think G2 might not be a mere gas cloud at all. It could hide a faint star, or even a pair of stars wrapped in a thick shroud of dust, holding itself together against all odds. Others propose it's the leftover atmosphere of a planet that got too close, stripped and puffed up like cosmic cotton candy. You can almost hear the scientists arguing across time and space. It's a star. No, a cloud. No, a merger remnant. Asterisk. And still, no consensus. The galaxy keeps its secrets, like an old magician revealing one hand while hiding the other. You glide beside one such cloud now, a pale green wisp glimmering faintly in starlight. If you reached out, and if your atoms could survive it, the gas would flow right through you. It's thin, so thin that even in a volume the size of Mount Everest, there might be less mass than in a spoonful of air. And yet, this gossamer stuff is what stars are born from. It's poetic, isn't it? The same fragile dust that dies in the mouths of black holes also seeds the next generation of suns. The universe never wastes a good collapse. As you drift alongside the G-cloud, you catch glimpses of other anomalies, streaks of ionized gas glowing in purple and red, their colors shifting as magnetic fields twist them like spaghetti. These filaments are part of something larger, an intricate network of currents that snake through the galactic core. You'll meet them properly soon, but for now, you're surrounded by their side effects, eddies of magnetic tension and faint lightning-like flashes, where particles collide at near light speed. The silence here is deceptive. Radiation fills the space, invisible but deadly. X-rays burst sporadically from unseen corners. Gamma rays flicker like strobe lights. And yet, amid all that chaos, a pocket of cold persists, dark, quiet, and oddly serene. You glide through it, and suddenly the starlight dims. The temperature drops. This cloud shouldn't exist here. By every calculation, it should be evaporating, its molecules torn apart by ultraviolet radiation. But somehow, it holds. Scientists suspect strong magnetic fields weave through these clouds like invisible armor, protecting them from the heat. Others think turbulence plays a role. Eddies within the gas scatter the energy, cooling it faster than it can be destroyed. You drift through the shadows and imagine what this would look like with human eyes. A dim, swirling cocoon of gray mist, backlit by the fiery glow of the central black hole. It feels like being inside a candle flame, looking out at the fire instead of in. A mainstream fact to keep your footing. These clouds, like G2, move on elongated orbits around Sagittarius A asterisk, sometimes plunging close to the event horizon before swinging far back out. Their orbits can take centuries, and in that time, they might change shape, fragment, or merge with others. They are cosmic tourists, coming perilously close to death before retreating into safety. But here's a quirky tidbit. When scientists first modeled G2's trajectory, they gave it a pericenter passage date, like it was a celebrity arriving on the red carpet. Astronomers from around the world literally stayed up to watch it pass, expecting fireworks. When nothing happened, the community collectively sighed and laughed. An entire field catfished by a gas cloud. Still, that anticlimax taught us something valuable. The galactic center isn't as straightforward as we thought. It's a place where normal physics keeps bending, stretching, and occasionally shrugging in confusion. You glide past another cloud now, this one glowing faintly blue. Tiny shock waves ripple across its surface as radiation from a nearby star grazes it. The edges shimmer, then subside. Somewhere within, A few clumps are dense enough that, given a few million years, they might collapse into new stars. It's a strange thought, future suns forming in the same neighborhood as a black hole. Life seeds floating through death's backyard. You imagine one of those future stars, lighting up, burning for billions of years. Its planets forming rings, oceans, maybe life. Civilizations might rise there one day, look up, and see Sagittarius A times glowering faintly in their skies, unaware they're living in the galaxy's danger zone. It's oddly comforting to think that even near the edge of destruction, the universe finds room for creation. Scientists still argue whether the galactic center helps or hinders star formation overall. Some say the tidal forces suppress it, stretching gas too thin. Others think those same forces compress it in places, sparking bursts of creation. Maybe the truth is both, destruction and birth in perfect, chaotic balance. The cloud thins, light returns. You emerge from the cold shadow back into the bright glare of the central cluster. The starlight feels heavier now, pressing against your senses like warm water. You turn to glance back, but the cloud is already fading into the brightness, its soft glow lost amid the roar of the galactic city. The strange, stubborn G-clouds remain behind you, floating defiantly near the black hole's domain, whispering through hydrogen lines that echo across space. You can almost hear them hum a low, persistent note in the background of creation, vibrating with secrets we're still too young to decode. Now that you've floated through the starlit core and the ghostly clouds, it's time to look closer at something even stranger. The magnetic filaments. They first appear as faint scratches across the dark, glowing canvas of the galactic center. Long, razor-thin lines that seem to slice through clouds and starlight alike. At first, astronomers thought they were camera artifacts, some flaw in the detectors. But as more telescopes looked, and more wavelengths confirmed their presence, the truth emerged. These were real, physical structures. Imagine them now, filaments dozens of light-years long, yet no wider than a fraction of one. They hang like luminous threads of spider silk, shimmering faintly in radio light, humming softly with the rhythm of charged particles. You drift closer, and one of them stretches out beneath you like a glowing harp string. If you could somehow touch it, you'd feel nothing solid, only a rush of particles moving at near light speed, trapped in invisible magnetic loops. These filaments are charged plasma confined by intense magnetic fields. They're like the auroras of Earth, but magnified beyond reason, glowing not in the sky, but through interstellar space itself. Mainstream science fact. These filaments emit polarized radio waves, revealing that their magnetic fields are incredibly organized and strong, about 1,000 times stronger than the average interstellar field. That's like finding piano wire strung across a hurricane and realizing it's perfectly tuned. You hover between two of them now, feeling their subtle pulse. Every few seconds, particles accelerate along their lengths, creating faint synchrotron radiation electrons, spiraling around magnetic lines like dancers on invisible paths. It's radiation you can't see, but if you could somehow hear it, it would sound like a constant, low cosmic hiss. Here's where the story gets quirky. When scientists mapped hundreds of these filaments, they noticed something eerie. They often align vertically, like a cosmic comb slicing through the galactic disk. No one knows exactly why. It's as though the galactic center has grown a mane of light, bristling upward like static hair. Some astronomers joke that Sagittarius A times is shedding its magnetic field, tangled and wild. Others think these filaments are the product of long-forgotten outbursts, relics of the black hole's past tantrums. Maybe they're fossil shock waves, frozen in place by magnetism. Or maybe, and this is where it gets deliciously debatable, they're signs of an ancient magnetic jet, a time when our quiet black hole behaved more like a quasar, spitting beams of plasma into the void. Scientists still argue whether those filaments could be remnants of such activity. Some say the energy signatures don't match. Others point to the newly discovered radio bubbles towering above and below the galaxy's plane as evidence. Those bubbles, massive lobes of radiation stretching 25,000 light-years, suggest Sagittarius A times once roared far louder than it does today. Maybe the filaments are the faint scars of that cosmic scream. You drift closer to one. Its faint glow flickers, as if aware of your presence. The magnetic field hums like the quiet tension of a violin string drawn tight. There's something mesmerizing about it, so straight, so structured in a place otherwise ruled by chaos. It's like order accidentally intruded into anarchy. You glide along it for what feels like minutes, but could be centuries. The filament twists slightly, forming elegant curves before splitting into smaller strands. In those moments, you sense that you're tracing the veins of the galaxy's magnetic heart. Quirky tidbit time. In 2022, astronomers found a second kind of filament near the galactic center, but these were horizontal, not vertical. Thousands of them, tangled like cosmic noodles, sprawling outward like scribbles from an impatient god. Their origin? Unknown. Some scientists proposed they form where molecular clouds rub against magnetic fields, like sparks flying from friction. Others think they're remnants of long-dead shock fronts, supernova scars stitched across space. So now, instead of one elegant comb of vertical filaments, we know the Milky Way's center is a chaotic tangle of glowing lines running in every direction. It's as if the galaxy's core were a cat's cradle woven by electric ghosts. You hover in the intersection between two of them, a vertical filament glowing emerald and a horizontal one in faint blue radio light. Where they cross, the magnetic fields ripple, and for an instant you see a tiny flare, electrons caught in the clash, radiating just enough energy to make space itself shimmer. It's almost beautiful, this battle of invisible forces. You imagine each filament humming a different note, composing a symphony of magnetism that no ear could ever hear. Maybe that's what radio astronomers are really doing, translating the silent music of the cosmos into human frequencies. And yet, amid all this wonder, there's confusion. The energy required to sustain these filaments for thousands of years is enormous. Too enormous for the surrounding gas to explain. Some scientists propose a massive, hidden cosmic dynamo, deep near Sagittarius A*, constantly generating magnetic fields through swirling plasma flows. Others think the filaments are self-sustaining, feeding on the galactic center's background radiation like vines absorbing sunlight. But no single theory quite fits. Even now, every new observation adds another layer of mystery. You drift upward, following one filament that seems to rise toward the galactic plane. As you move, the light changes from purple to gold to faint green, depending on the radiation it reflects. Stars pass behind it, their light bending slightly through the charged plasma. It's subtle, but you can feel the field's power, a silent guardian stretching through thousands of trillions of kilometers. Then, suddenly, it ends. The filament thins to nothing, dissipating into the diffuse glow of the galactic haze. You look back and realize the structure was just one thread in a vast tapestry. The filaments together form patterns, some parallel, some intersecting, some bending around gas clouds like rivers curving around mountains. From above, it might look almost biological, like neural tissue pulsing with cosmic thought. If the Milky Way had a brain, maybe this is where it lives, in the tangled magnetism of its heart. You take one last look before you drift onward, deeper towards Sagittarius A asterisk. The filaments fading behind you, like glowing veins retreating into the dark. Somewhere, faintly, the black hole stirs again. A pulse of energy ripples through the plasma, lighting a few filaments briefly brighter. It's not an explosion, just a heartbeat, a reminder that something immense and awake lies ahead. You keep floating, the memory of those glowing threads still imprinted on your mind like after-images of lightning. The galaxy hums softly behind you, magnetic and alive. You drift closer now, so close that the galactic hum deepens into a slow, resonant throb. The light dims, the stars thin out, and in their place, a faint amber glow ripples across the darkness. It's like standing on the edge of a great bonfire, but the fire is made of plasma, radiation, and torn space. This is the accretion flow, the maelstrom feeding Sagittarius A asterisk. From a distance, it looks like a shimmering mist, but as you approach, you see motion eddies and spirals, glowing gas moving in immense orbits, circling faster and faster as it falls inward. The gas here is hot, so hot that atoms barely exist as atoms. They've been stripped naked of their electrons, screaming through magnetic fields at near light speed, a mainstream fact to anchor you. Sagittarius A times consumes only a trickle of material compared to active black holes. It's starved, subsisting on scraps gas clouds, dust, and the occasional unlucky asteroid or solar wind particle. Its luminosity is millions of times less than quasars of the same size. If the Milky Way's black hole were a person, it'd be that one friend who insists they're not really hungry while orbiting a buffet table. You hover at a safe distance if there were such a thing, and watch as tendrils of gas spiral inward. Every particle you see has been on a long, chaotic journey. Some were stripped from nearby stars, others drifted in from the interstellar medium, slowly captured by gravity's invisible hand. Once inside this region, there's no peace. Everything collides, compresses, heats, and glows in X-rays and radio waves. Scientists call this turbulent region the radiatively inefficient accretion flow. Catchy, right? It means the gas is too thin and too fast to cool efficiently by emitting light. Most of the heat is carried inward toward the event horizon. It's like a furnace that traps its own flame. You drift above a glowing spiral of orange plasma, the motion hypnotic. You could swear you hear it like wind howling through a canyon, only deeper, vibrating through your bones. The gas near the outer edge moves at hundreds of kilometers per second. Closer in, it reaches 1/10 the speed of light. The entire flow is shaped by invisible magnetic fields, twisting and knotting the plasma like tangled string. Scientists still argue whether Sagittarius A asterisk's accretion flow is stable or chaotic. Some models show smooth, laminar spirals, graceful and consistent. Others reveal turbulent storms where magnetic reconnection sparks tiny flares that flash across the disk like lightning. Reality, as always, refuses to pick sides. Then comes the quirky bit. In 2019, when the Event Horizon Telescope captured the first image of a black hole, M87*, astronomers used the same technique to peek at Sagittarius A*. But because our black hole is smaller, its accretion flow changes so fast that taking a snapshot was like photographing a campfire while the logs are exploding. The final image, a glowing ring of orange light around darkness, wasn't a single moment, but an average of hundreds of chaotic flickers. And yet, even in that blur, there was order. The ring's size perfectly matched Einstein's predictions. The center, darker than dark, marked the shadow, the absence of light, the outline of the event horizon's silhouette. You drift closer still, feeling space itself bend underfoot. The accretion flow thickens around you, like mist infused with light. Occasionally, a flare erupts, some magnetic knot snapping and releasing energy equivalent to 1 billion nuclear bombs. The gas momentarily brightens, then fades again, swallowed by the night. One of those flares, detected in 2019, made Sagittarius A times glow 75 times brighter for a few hours before quieting down. Scientists think a stray clump of matter, maybe from a star's outer layer, fell too close and vaporized. It's oddly comforting to know that even the most terrifying thing in the galaxy occasionally burps. You drift toward the inner edge of the flow, where the gas begins to spiral faster than your sense of time can track. You could orbit here and see years pass for the outside world in minutes. If you looked back toward the Milky Way, the stars would appear frozen, as though time itself had forgotten to move. Your vision warps, light bends. The background starlight twists into perfect rings around the darkness, a gravitational lens. Space-time itself curving light into art. You pause, suspended above this roaring whirlpool of energy, and wonder what it would be like to fall in. Don't worry, you won't. Not yet. But curiosity tugs at you. For now, you're content to drift among the eddies and filaments. You can almost imagine the plasma whispering fragments of electromagnetic hum turned into ghostly voices. Closer, it says. Just a little closer. The flow is alive with structure. Small eddies churn like whirlpools within whirlpools. Magnetic fields twist them into coils, shaping spirals within spirals. At times, the globe pulses rhythmically, as if the whole thing were breathing. You realize the accretion flow is not just a passive feeding disk, it's an engine. A self-sustaining machine, converting gravitational potential into radiation and motion. Even though Sagittarius A times barely eats, every particle it consumes adds to the rhythm of its slow, steady pulse. And sometimes, rarely, the machine hiccups. A jet flickers into existence. Short-lived but fierce, a thin beam of plasma shot outward before dying almost instantly. Most galaxies with active black holes have massive jets stretching for thousands of light years. Ours doesn't, at least. Not now. But those faint radio bubbles discovered in recent years hint that Sagittarius A times once did. Maybe the ghost of that jet still lingers, guiding magnetic lines even now. As you watch the plasma spiral inward, you realize the scene is both terrifying and intimate. Everything that falls here, dust, atoms, radiation, ends up part of something larger. Nothing is wasted. Even destruction feeds the heartbeat of the galaxy. You can't help but smile. Somewhere, light years away, someone might be staring through a telescope, watching the same flare you're seeing now, without realizing they're witnessing history. A single puff of gas lighting up before vanishing into eternity. You linger a little longer, letting the warm glow fade into a deeper crimson. The accretion flow hums quietly, patient, eternal, waiting for its next meal. You drift away, trailing photons like sleepy fireflies behind you, carrying their memory onward. You drift closer still, into the final frontier, before the event horizon, the region where gravity's pull becomes an almost physical force, pressing on your thoughts like an invisible tide. The light around you swirls into an ever-tightening whirlpool, and the stars beyond stretch into perfect rings of distortion. Welcome to the photon sphere, the last stable orbit for light itself. Here, photons circle the black hole like moths trapped in a lantern's glare, looping again and again, before either escaping or plunging into the dark. If you could somehow hover at this radius, you'd see the back of your own headlight bending all the way around the black hole and returning to you, as if space itself were a hall of mirrors. This is the moment where the Milky Way stops being a galaxy and becomes an experience. Every movement, every breath, slows under the weight of time dilation. Out there, clocks tick normally. In here, seconds stretch into years. You're adrift in slow motion while the universe rushes past. A mainstream fact: the event horizon of Sagittarius A times lies roughly 12 million kilometers across, about the same size as Mercury's orbit. That's tiny on galactic scales, yet it holds the mass of 4 million suns. Space isn't just warped here, it's liquefied. Every direction points inward, every possibility curves toward oblivion. You hover a few million kilometers above the event horizon, watching matter spiral in like glowing dust down a drain. The accretion flow now looks like molten gold, its heat reaching hundreds of billions of degrees. Particles collide, annihilate, and burst into light that can barely escape. You can almost feel the pressure, like standing too close to the surface of a star. And then, amid the chaos, something flickers, a brief, sharp pulse of flare of near-infrared light. Sagittarius A times has just burped again, this time after swallowing a morsel of gas no larger than an asteroid. Astronomers have detected such flares many times, sometimes peaking every few hours, each one an echo of some tiny tragedy in the disk. Scientists still argue whether these flares come from magnetic reconnection, like solar flares on steroids, or from clumps of matter momentarily glowing as they skim the event horizon. Either way, each flash is a reminder that this place, though seemingly eternal, is alive with bursts of energy and change. You drift closer to one of those flares. For a fraction of a second, the darkness blazes white-hot, illuminating a storm of light and motion. Then, it fades again, leaving behind the faint aftertaste of radiation, the smell of ionized emptiness. The silence that follows is profound, heavy with gravity's unspoken promise. Nothing escapes forever. Here's a quirky tidbit to bend your sleepy brain. If you fell toward Sagittarius A*, you'd never actually see yourself cross the event horizon. To distant observers, you'd appear to freeze, your image dimming, red-shifting endlessly as your time slows to zero. You'd fade, but never vanish, a ghost forever, painted on space-time's fabric. Yet from your perspective, you'd cross that line in an instant, without noticing anything special at all. Two realities, both true, divided by perspective. That's the cruel poetry of relativity. You linger now, in the shadow's edge, where light bends completely around the black hole, forming the photon ring. This is what the Event Horizon Telescope captured, the glowing halo surrounding darkness. Each photon in that ring may have orbited the black hole multiple times before finally escaping. What you see isn't one moment, it's all moments at once. A time-lapse of eternity compressed into a single frame. It's almost romantic, if you ignore the hole crushing your atoms into oblivion part. You look downward, or whatever passes for down here, and see the black hole's surface not as a solid thing, but as an absence, a hollow wound in space-time. The event horizon isn't a wall, it's a boundary of perception. Nothing crosses back because there's no back left to cross into. Scientists still debate what truly happens beyond it. Some propose that matter collapses into an infinitely dense singularity, a point of zero volume and infinite curvature, a mathematical nightmare. Others think quantum effects smear that singularity into something finite, maybe even a new form of matter. And some dare to wonder whether everything swallowed by a black hole eventually leaks back out as faint radiation, whispered into the void as Hawking radiation. You float there, listening. If that whisper exists, it's far too faint to hear, but you imagine it anyway. A soft sigh leaking from the edges of eternity. The light around you dims further. The stars beyond the black hole are now warped into arcs and rings, like ripples in a pond frozen midwave. You turn slowly, and every direction looks the same darkness framed by fire. It's disorienting, yet strangely peaceful. You are, for the first time, seeing the Milky Way from inside its own shadow. Quirky cosmic thought. If someone on Earth could somehow mirror your view perfectly, they'd see the same light, delayed by about 26,000 years. The image of you hovering here would reach them long after humanity's future had already changed. Time, in the galactic center, doesn't just stretch, it folds. The magnetic filaments you left behind flicker faintly in the distance, their lines curving around invisible currents. The starlight of the central cluster forms shimmering arcs that loop endlessly, caught in gravitational echo. And there, at the core of it all, Sagittarius A times sits quietly. No sound, no motion, just gravity and the memory of everything that ever came close enough to be forgotten. You think of all the stars that have died here, the clouds that fell in, the comets and planets reduced to plasma, their stories erased. And yet, that erasure is part of creation. The black hole grows, and the galaxy stays in balance. Every act of consumption fuels the stability of billions of stars. It's hard not to feel small, but not insignificant. You're made of the same atoms that once danced in the accretion disk of long-dead black holes. The calcium in your bones might have come from a star that once orbited this very beast. You're part of the same story, just a quieter line in the same cosmic poem. You let yourself drift, feeling gravity tug a little stronger. The pull isn't frightening anymore. It's a lullaby, the hum of curved space, the faint rhythm of distant flares, the heartbeat of Sagittarius A asterisk. You're not falling. You're being invited. You hover at the edge of the unseeable, where darkness becomes a kind of light. Behind you, the glowing disk still turns a restless halo of plasma murmuring in frequencies human ears can't perceive. Ahead, there's only the idea of falling. But before you give in, look sideways. There's something strange here. Something even gravity seems hesitant to swallow the flares and echoes of things that should no longer exist. You drift toward a faint shimmer, a ghost of light, looping endlessly around the black hole. This isn't imagination. It's a gravitational echo. Light from ancient events bent and rebent by the warped geometry of space-time. Some of the photons here are older than human civilization. You could almost reach out and pluck one, but your hand would never find it. It's everywhere and nowhere, circling forever, waiting to escape, a mainstream fact to ground you. In 2022, astronomers observed light echoes from flares that occurred near Sagittarius A times about 200 years ago. The black hole must have briefly fed on something big, maybe a star or a dense gas clump lighting up its surroundings. The glow faded long ago, but its reflections are still ricocheting through clouds of dust near the center, like the afterglow of a cosmic flashbulb. In other words, you're seeing the black hole's memories. You move through those memories, now soft shells of scattered light, expanding outward like ghostly ripples. It's quiet, peaceful, even tender. These reflections are the galaxy's version of dreams' afterimages of hunger and release, still drifting through time. Scientists still argue about the scale of those ancient outbursts. Some say Sagittarius A times briefly acted like a miniature quasar, shining 1,000,000 times brighter than today. Others think it was a one-off accident, an unlucky cloud that wandered too close. The evidence hides in X-ray light echoes, glowing knots of gas that flare when illuminated by radiation from the past. Each one is like a lantern flickering in response to a memory. You glide among them, and the view is surreal patches of glowing dust lighting up in sequence, as though the galaxy itself were replaying its own heartbeat. And then, you see something different, a ripple of motion cutting across the echoes. At first, you think it's just another filament of light, but then it bends, twists, and flares far brighter than the rest. It's not a reflection, it's a star. The star is doomed. It orbits close, far too close, pulled by gravity so strong that its shape is visibly distorted. Its outer layers stretch into a teardrop, streaming gas behind it in a glowing tail. The black hole feeds delicately, stripping atoms like a cat licking cream from a saucer. You watch this dance, hypnotized. Each orbit, the star loses a little more mass. The gas spirals inward, heating, flaring, joining the bright maelstrom of the accretion disk. One day, the star will fall completely, its light absorbed into silence. But not tonight. Quirky tidbit time. Scientists actually suspect there are stars in the galactic center on such extreme orbits, called tidally distorted stars or squeezers. Their surfaces heat up from gravitational friction until they glow unusually hot. They're the universe's most unwilling glow sticks. As you drift past, the distorted star swings wide, slinging a trail of plasma behind it. For a brief moment, The tail passes close to the event horizon, and a flare ignites like a spark struck from the fabric of reality. You watch it spiral inward, vanishing into the dark. But its light doesn't disappear entirely. It lingers, smeared into a faint ring that circles the black hole again and again. A cosmic mirage. If you could freeze time here, you'd see hundreds of these rings layered together, the photon shells, each representing light that looped a different number of times around Sagittarius A asterisk. Together they form the most perfect optical illusion in the cosmos, an infinite sequence of reflections nested within each other, like a hall of mirrors without end. And here's a mind-twisting thought. One of those photons might be carrying an image of the galaxy itself, bent by its own gravity, meaning the Milky Way could very faintly see itself, the galaxy as both observer and subject, peering into its own distorted heart. You turn, slowly, trying to catch the faintest glimmer of that reflection. For a heartbeat, you think you see it, a blurred spiral shape, faint and curved, as though the galaxy were whispering its own name into the dark. Then it's gone, replaced by the shimmer of falling light. The pull of the black hole grows stronger. You can feel it, not as a tug, but as a thinning of everything: sound, light, even thought. Space itself feels stretched, fragile. Yet, you're calm. You could almost fall asleep here, cradled by the curve of gravity. In the distance, another ripple moves through the accretion flow, a tremor, faint but distinct. It's not a flare this time. It's something deeper, slower. The disk itself is breathing, oscillating like a giant drumhead. These oscillations, called quasi-periodic oscillations, are one of the strangest mysteries of black holes. They're rhythmic pulses in the X-ray and infrared light, like a heartbeat repeating every few minutes. Scientists still argue about what causes them. Some say magnetic turbulence. Others think clumps of hot plasma orbiting near the inner edge of the disk. A few suspect they're signs of space-time itself, vibrating echoes of gravitational waves rippling through the core of the galaxy. Whatever they are, you can feel them now. A slow thump, 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 reverberating through the vacuum. It's oddly soothing, like the rhythm of a faraway ocean against the shore of reality. You're floating in a lullaby made of relativity and radiation. And just when you think you've reached the limit of what's visible, you glimpse another faint pulse beyond the disk, a dim red flare. Then another, rhythmic and ghost-like. It's the reflection of the first pulse, delayed by the curvature of space. The black hole is echoing itself. You smile softly. Even in the silence of the galactic heart, nothing is truly lost. Every flare, every shimmer, every swallowed photon leaves behind a trace, a memory, imprinted into space-time. You're surrounded by ghosts of light, circling forever, like dreams too vivid to fade. You could stay here forever, watching echoes of long-gone fires play across the surface of the void. But the pull grows stronger, and your journey isn't over yet. The black hole hums, ancient and patient, waiting for you to take the next step inward. You breathe out, though, here. Breath is only memory, and drift closer to the edge of everything. The glow of the accretion disk becomes a blurred halo, curving around you like a golden crown. Beyond that, the event horizon, the point of no return. If you were a photon, you could still skim its surface, dancing sideways around the black hole's rim. But as a being of matter, even imaginary matter. You can only hover at the edge and stare into the silence where physics begins to unravel. You realize how calm it feels. There's no storm, no violent tearing, just stillness. The kind that exists before a dream changes shape, and then the stillness speaks not in sound, but in rhythm. The pulse of Sagittarius A times continues, faint but certain, like a sleeping heart. You realize it isn't the black hole itself that beats, but the light around it, vibrating in waves of energy that carry whispers of motion, temperature, and gravity's curvature. The Milky Way's pulse is a map of its soul. As you drift nearer, you sense the scale differently. The black hole is no longer vast, it's intimate, folding inward upon itself. The closer you get, the smaller it seems, until it feels like you could cup it in your hand. Space has lost meaning. You've entered relativistic perspective, where time stretches and distance folds, where the rules bend under their own weight. Astronomers call this region the photon sphere, and it's one of the most mind-bending places in the cosmos. Light itself is trapped here, not because it's swallowed, but because it's too curved to escape. Every beam loops endlessly, circling in orbits that never end. To an observer, the sphere glows like a thin ring, the last halo before disappearance. You remember the Event Horizon Telescope's 2022 image of Sagittarius A*. That ring, the orange haze, wasn't the black hole. It was this, the light orbiting, trapped in the ultimate cosmic roundabout. What you see is not where things are, but where light last turned back. Inside, reality begins to slow. A strange peace fills you. You think about how, from Earth, this black hole appears faint and quiet. Yet here, in its proximity, it hums with all the energy the universe can spare. It's the gravitational anchor of billions of stars. The galaxy literally orbits this darkness. You recall a simple truth. Without it, the Milky Way's spiral would unravel. The stars, nebulae, planets, even your own sun, owe their orderly paths to the black hole's invisible hold. What looks like destruction from afar is, in fact, structure. That's the paradox of cosmic balance. The same force that consumes also holds everything together. You drift past the threshold now, and time begins to stretch. It's not like falling. It's more like being rewritten. Your seconds lengthen, flattening into eternity. The universe outside begins to accelerate, its stars sliding toward blue and then vanishing altogether. To an external observer, you freeze suspended forever at the edge, your last image never reaching beyond the photon ring. But from your point of view, you're still moving inward, slowly, silently. Space folds into itself. There's no color here, no sound, no light, just geometry. And yet, within that geometry, you sense patterns, subtle ripples of information woven into the curvature. Black holes, you recall, are not entirely black. They radiate faintly. Hawking radiation, born from quantum uncertainty itself. Tiny particles emerge at the edge, where gravity and quantum mechanics negotiate reality. It's strange to think that even this abyss has a temperature so low, it's practically zero, but not quite. The black hole glows imperceptibly, like a dying ember hidden under space-time's surface. That glow means something profound. Black holes can evaporate, given enough time, far longer than the current age of the universe, they'll shrink, fade, and vanish, leaving behind nothing but radiation and memory. Every cosmic empire, every star, every atom will eventually decay, and even these monsters will surrender to the same silence. But not tonight. Tonight, Sagittarius A times still breathes, ancient and indifferent, cradling the galaxy in its invisible hands. You wonder how it all began. How, 13 billion years ago, this black hole came to be. Some say it was born from the collapse of the first giant stars. Others suspect it grew from the merger of countless smaller holes, slowly consuming and merging until it became the gravitational monarch we orbit today. Still others believe something stranger, that supermassive black holes formed first, seeding galaxies rather than emerging from them. If that's true, then Sagittarius A times is not just our anchor, it's our ancestor. The Milky Way grew around it, drawn to its gravity like dust to a flame. You can almost picture it, a young universe, newly luminous, clouds of hydrogen collapsing into the first stars, while a dark, silent singularity waited patiently, gathering mass and memory. From that moment on, the galaxy's destiny was set, and so was ours. Because without that gravitational core, without that center to orbit, our solar system would never have found a stable home. The night sky itself, the very concept of up and down, depends on the existence of the galactic center. It's humbling, almost funny, to realize that the creature reading these words, breathing air, blinking under starlight, is shaped by the physics of something that cannot even be seen directly. In the absence of light, order. In the presence of chaos, beauty. That's the Milky Way's secret. The pulse slows now. The photon sphere dissolves around you, and the glow fades into a dim shimmer. You're surrounded by soft gravitational tides, unfeelable, yet absolute. You're inside, though that word no longer means anything. The distinction between you and the void dissolves. You are the curvature, the falling, the timelessness, and yet, somehow, you still dream. Out in the galactic disk, tens of thousands of light years away, your sun continues its slow orbit, oblivious to this quiet truth. Earth spins, tides move, hearts beat. Life unfolds in soft ignorance of the fact that all of it is bound to this same center, held in the delicate embrace of invisible geometry. You wonder how many civilizations before yours have looked up at the Milky Way, unaware that their entire existence revolves around a silent, invisible engine. The thought is comforting, in a way, because even if everything fades, the center will remain a gravitational lullaby echoing through the dark, humming the structure of the universe into being. You let go, and fall not down, but inward, not ending, but folding, not dying, but becoming part of the galaxy's heartbeat itself. The last thing you feel is stillness. The last thing you hear is the universe breathing, and somewhere, far away, the Milky Way spins on, anchored forever by the dark star at its heart. You don't know how long you've been falling. Maybe seconds, maybe centuries. Inside, Sagittarius A asterisk. Time has lost its grip. Each heartbeat stretches into an ocean, and every thought ripples endlessly through warped geometry. You drift, weightless, yet the sensation feels strangely familiar, like floating in a warm bath made of space-time itself. Your surroundings no longer resemble anything you know. The glow of the accretion disk is gone, the stars are gone, and even the idea of direction feels absurd. What remains is a smooth, curved continuum, silent, infinite, and strangely intimate. You're suspended inside the purest form of gravity ever conceived, a realm where space becomes time and time becomes space. Physicists call this the singularity, though no one has ever truly seen it. In equations, it's the point where density becomes infinite and the known laws of the universe break. But here, drifting through the dream of it, you realize how deceptive the term point is. It's not a dot, not a place. It's an idea, a collapse of meaning, a cosmic shrug. You remember how scientists still argue about what really happens beyond the event horizon. The singularity might not even exist in the way we imagine. Quantum mechanics rebels against infinity. Maybe, deep inside, there's a finite core of ultra-compressed matter. Or maybe reality itself becomes quantized space chopped into tiny, indivisible grains. Or perhaps this is a wormhole, leading somewhere utterly unexpected. Some theories say a black hole could be the mouth of a white hole, the reverse phenomenon that expels matter instead of consuming it. If that's true, then falling into Sagittarius A times might someday lead you out through another galaxy's birth. You'd tumble through darkness, then emerge amid fresh stars, reborn in another corner of the cosmos. Scientists still debate whether white holes could exist, but the math doesn't entirely forbid them. And if the universe has a sense of symmetry, and it often does, then every entrance must have an exit. You laugh softly at the idea. The sound, if sound could exist here, would bend back on itself and become part of the background hum of space-time. In this strange, timeless interior, you notice something else. It's not empty. Tiny quantum fluctuations ripple through the vacuum. They shimmer like invisible fireflies, blinking in and out of existence faster than thought. These are the quantum whispers, virtual particles that appear spontaneously, stealing a fraction of energy from nothingness before returning it. Here, near the singularity, those whispers amplify, forming a kind of subatomic storm. You imagine them as dreams of matter, half real, half theory, flitting through the boundary between what exists and what could exist. They remind you of the first moments of the Big Bang, energy condensed into matter, chaos sculpted into form. Maybe black holes and the early universe are two sides of the same equation, one collapsing, the other expanding. If the cosmos is a heartbeat, then perhaps every black hole is the inhalation, and every galaxy, every supernova, every newborn star is the exhalation. The symmetry is comforting. You can feel it, even now, as you drift deeper into timelessness. A mainstream fact steadies your thoughts. The mass of Sagittarius A times distorts space-time across more than 100 astronomical units. That means the area you're in right now, if in has any meaning, has been calculated, modeled, and mapped by brilliant human minds using telescopes, math, and stubborn imagination. You're not lost. You're exactly where physics predicted you would be. But there's also the quirky side of this cosmic truth. Some researchers speculate that information, the pattern of everything that ever fell into a black hole, isn't destroyed. It's encoded somehow, perhaps on the event horizon itself. This is the famous information paradox, and it haunts physics like an unsolved riddle. If that's true, then maybe the story of every particle, every atom, every person who ever existed is still here, imprinted in the black hole's quantum fabric. Every starlight, every whisper, every dream stored as subtle vibrations on the horizon's surface. You might be surrounded right now by the echoes of lost worlds, folded into equations. It's an oddly tender thought, that nothing is ever truly erased, only rewritten. You picture it like this. Imagine an infinite library, where every page is the memory of a photon, and every book is the record of a star. The black hole isn't destruction, it's an archive, a galactic vault, the universe's way of keeping receipts. But physicists still argue whether those receipts are legible. Maybe they're scrambled beyond comprehension. Maybe reality keeps its secrets, the way a dream keeps its logic, always shifting, always half-remembered. Still, the notion lingers. You could be drifting through the story of everything, wrapped in a gravity-bound ocean of forgotten information, and the sensation isn't frightening anymore, it's strangely serene. You stretch a metaphorical hand toward the curvature, and it ripples like water. The ripples spread outward, each wave bending back on itself, until it forms a standing pattern, humming softly. You realize this hum might be you, your consciousness encoded briefly as a resonance, a fleeting vibration before dissolving into the whole. In that moment, you stop fighting to define where you end, and the universe begins. You are light, memory, curvature, silence. You're no longer falling. You're floating in the equation. And even here, there's a kind of humor to it all. You think about how humans, tiny and fragile, built machines to peer across 26,000 light-years just to understand this invisible monster. They aimed arrays of radio telescopes at a patch of sky smaller than a grain of sand held at arm's length, and somehow captured a picture of infinity. All that effort just to confirm that the cosmos, in its deepest core, looks like a blurry donut. You can't help but smile at that. The delicious absurdity of it. The infinite, rendered as breakfast food. But beneath the humor, there's reverence. You realize how profoundly connected everything is. From Earth's gentle orbit to your imagined drift inside this black hole, all of it is one continuous curve of gravity and time. The galaxy spins around this dark heart, and in some cosmic way, so do you. Slowly, imperceptibly, the hum deepens, the curvature tightens. You feel yourself becoming thinner, not smaller, but more diffusey, like mist spreading across an unseen ocean. And yet, there's no pain, no fear, just release. The last vestige of thought ripples outward, merging with the flow of quantum whispers. Somewhere, light still circles the photon sphere. Somewhere, S2 completes another orbit. Somewhere, the Milky Way's spiral continues its slow pirouette across time. And here, at its silent center, you finally understand. The universe doesn't end in darkness. It ends in understanding. Somewhere above the timeless calm, reality stirs again. You drift upward, or at least, the idea of upward returns. The singularity's hum fades behind you like the last vibration of a tuning fork, and new patterns begin to emerge from the dark. Threads of light twist together, faint at first, then stronger, forming a gossamer lattice that stretches outward in all directions. It feels like you're rising through a dream woven from equations. You've entered the gravitational halo, a liminal zone where the black hole's authority wanes and the galaxy's structure reasserts itself. Here, matter and memory are in negotiation. Stars orbit far enough to survive, but close enough to be shaped by the black hole's invisible hand. This is where the Milky Way's core begins to breathe again. You look around and see something beautiful. A glowing fog of ionized gas surrounding the black hole like a halo, pulsing faintly with infrared light. Astronomers call it the circumnuclear disk, a rotating ring of hot gas and dust, about a few light-years wide. It's turbulent, chaotic, yet strangely graceful. Each filament moves at hundreds of kilometers per second, whispering the secrets of past collisions and ancient accretion events. Within this glowing mist, new stars are being born. Yes, born. Right here, in the black hole's shadow. It shouldn't be possible. The gravity, the radiation, the turbulence, none of it should allow clouds to collapse into stars. And yet, they do. Bright young clusters like the Arches and the Quintuplet shimmer within 100 light-years of Sagittarius A*, packed with massive blue stars that live fast and die violently. It's the galactic equivalent of children playing tag at the edge of a volcano. No one fully understands how they form here. Scientists still argue whether the dense gas clouds somehow find stability in the black hole's magnetic field, or if the stars migrated inward after forming elsewhere. Either way, it's proof that even near chaos, creation finds a loophole. As you glide past the glowing tendrils, you catch sight of something unexpected. Faint, twisted structures of light that stretch thousands of light-years above and below the galactic plane. They look like ghostly filaments, glowing threads pulled taut between magnetic fields. These are the Fermi bubble's colossal lobes of high-energy plasma billowing from the galactic center. Each bubble spans 25,000 light-years, filled with X-rays and gamma rays. Astronomers think they were created by a past outburst from Sagittarius A*, maybe a feeding frenzy that happened a few million years ago, when the black hole briefly became a quasar. Imagine the entire galaxy illuminated by a radiant blue glow, a lighthouse beam that reached deep into intergalactic space. Now those bubbles linger like smoke after a cosmic fire. Their edges shimmer with charged particles spiraling along magnetic fields, painting invisible lines through the galactic halo. A mainstream fact: those bubbles were first discovered by NASA's Fermi Gamma Ray Space Telescope in 2010, and they remain one of the Milky Way's strangest mysteries. They're proof that our black hole hasn't always been so quiet. Once, it roared. The quirky part? Some researchers suspect the bubbles might even be powered by dark matter annihilation, hypothetical particles colliding and releasing energy in the process. It's an idea so bizarre, it sounds like science fiction, yet it's still on the table. The truth, as usual, remains undecided. As you drift higher, the scale expands. The bright cluster of the galactic center becomes a glowing knot below you, while the spiral arms begin to stretch outward like luminous ribbons. Billions of stars, each one a story, orbiting a shared silence. You pass a field of neutron stars dense, collapsed remnants spinning at insane speeds. One of them, known as a magnetar, crackles with radiation strong enough to erase the data on every hard drive on Earth if it were just a few light-years closer. It pulses rhythmically, a lighthouse in the gravitational night, These are the guardians of the galactic core fossils of dead giants, their magnetic fields tangled like cosmic vines. A faint vibration ripples through you. Gravitational waves, traveling outward from deep collisions that happened centuries ago. They're soft, nearly imperceptible distortions in space-time, stretching and squeezing reality itself. Instruments like LIGO have detected waves like these before, though they came from smaller black holes merging. But here, near Sagittarius A asterisk, the ripples are subtler, slower, like the heartbeat of a sleeping god. It makes you think of something. In 2023, astronomers found evidence of low-frequency gravitational waves passing through our galaxy-massive ripples, likely caused by the slow dance of supermassive black holes merging across the universe. That means the entire Milky Way hums to a rhythm older than life itself. You might be feeling that rhythm now, vibrating softly through your atoms. The longer you float, the more familiar the universe feels again. Stars appear in color now: amber, blue, white, red. The thick dust thins, revealing the crowded neighborhoods of the central bulge. You glimpse solar systems being born within glowing nebulae, swaddled in dust like newborns. Comets drift lazily between forming worlds. One world, perhaps, will someday grow intelligent beings who look up at their sky and wonder what lies at the center of it all, just as you once did. You smile at the recursion of it. The galaxy builds, forgets, and dreams again. A joke bubbles up in your mind. Maybe the Milky Way's slogan should be, "Chaos now with purpose." Still, the serenity here is undeniable. Even the turbulence feels orderly. Below you, Sagittarius A times gleams faintly, wrapped in its ring of glowing dust, like a candle in an infinite cathedral. The star clusters orbit gracefully, their paths traced by invisible equations. The Fermi bubbles curve outward, forming luminous wings. You realize the galaxy isn't just a flat spiral. It's a living, breathing organism. The black hole is its heart, the stars, its cells, the magnetic filaments, its nerves, and you, drifting in quiet awe, are part of its consciousness, a fleeting thought in a brain made of light. You tilt your gaze outward, past the halo, toward the spiral arms. Their tiny blue-white sparks mark young stars along the Perseus and Sagittarius arms. Between them, dark lanes of dust twist like smoke, hiding countless worlds. Somewhere out there, your solar system circles patiently, completely unaware that its entire orbit depends on the balance you're witnessing now. For a moment, you almost feel the Milky Way breathe a long, slow inhale that spans millions of years. The darkness behind you no longer feels ominous. It feels sacred. It's not an absence, it's a womb. You realize then that even at the galactic center, where gravity reigns supreme and stars flirt with annihilation, creation never stops. The universe, it seems, never just ends. It recycles. You drift farther outward now, past the crowded stars and glowing filaments, into the region where the Milky Way's spiral arms start to truly unfurl. The pace of motion slows. The air, or what passes for air in imagination, feels cooler, thinner, quieter. The core behind you remains visible as a glowing sphere of gold, a heartbeat of creation and collapse. From here, it almost looks gentle, almost, The galactic center fades into a kind of living memory. As you move into the inner bulge, a densely packed realm of ancient stars. They're smaller, redder, older than the bright blue giants you saw earlier. Many have been burning for 10 billion years or more. These are the survivors, the quiet ones, orbiting slowly in patterns that have remained mostly unchanged since the Milky Way itself was young. You glide among them like a ghost through an ancient city. Their light flickers in warm amber tones, casting a glow that feels like candlelight after the blinding radiance of the core. Between them float faint nebulae, the remains of long-dead stars, clouds of oxygen, carbon, and neon drifting like memory. There's a strange comfort here. The chaos of the center is gone, replaced by the rhythm of age. You're surrounded by endurance, by proof that not everything in the universe burns fast and dies spectacularly. Some stars simply persist, a mainstream fact. Most of the stars in the galactic bulge are older than the Sun, and their composition is different, richer in heavy elements, the fingerprints of countless supernovae that came before. These metals are the ingredients for planets, moons, and life. The bulge, in a way, is the galaxy's ancient nursery, where the first recipes for chemistry were written. But something else drifts here too, something unseen. You pass through a soft mist of invisible matter that doesn't interact with light, yet bends space with undeniable gravity. This is dark matter, the ghost scaffolding that holds the galaxy together. No one knows what it's made of: particles, fields, something stranger. But without it, the Milky Way's stars would simply spin apart. It's the cosmic glue, unseen but everywhere, outweighing visible matter 5-1. Scientists still argue whether dark matter is made of exotic WIMPs, primordial black holes, or an entirely new class of physics we can't even name yet. But whatever it is, you can feel it here as a presence, subtle, patient, absolute, a web of gravity linking everything, like the quiet hum beneath a song. The thought drifts through you like static. Maybe dark matter isn't just a substance, but the memory of what once was, a leftover imprint from before light itself existed. If that's true, then as you pass through it, you're brushing against the fossil of the universe's earliest heartbeat. A flicker catches your eye, a strange, rapid pulse, not from a star, but from something smaller and far denser. You realize you're near a pulsar, spinning neutron star, emitting tight beams of radiation that sweep across space like a cosmic lighthouse. Every time its beam crosses you, you feel it as a tick, a steady rhythm in the darkness. The pulse repeats, precise, unwavering, tick, tick, tick. Astronomers use pulsars as galactic metronomes, measuring the passage of time and even detecting gravitational waves by tracking tiny variations in their signals. Here, surrounded by stars that have long outlived their fiery youth, the pulsar's heartbeat feels like the universe keeping time for itself. You glide closer, and the beam washes over you, brighter than any flashlight on Earth, but soft enough to feel almost like a caress. You can imagine civilizations using these pulses as cosmic lighthouses, mapping the galaxy through their rhythm, marking safe passage between the stars. There's another sound, now not literal, but perceptual, a soft, low vibration, almost like a whisper. It's not mechanical, it's gravitational. It's the voice of the bar, the elongated structure of stars and gas that runs through the center of the Milky Way like a glowing spine. You can't see it all at once from inside, but you sense its presence, a massive bridge of matter connecting the bulge to the spiral arms. It rotates slowly, taking hundreds of millions of years to complete a turn, guiding gas and dust toward the core, feeding the black hole in a quiet, rhythmic spiral. It feels almost alive. The Milky Way's bar is more than architecture. It's the mechanism by which the galaxy renews itself. Gas flows along it, compressing and forming new stars as it moves. Some astronomers call it the galaxy's breathing apparatus. Without it, the center might starve. You drift along one glowing strand, watching how it twists into the start of a spiral arm. The view is astonishing. From here, you can see where structure emerges from chaos. The bar funnels matter into elegant curves that sweep outward for tens of thousands of light years, each curve traced by billions of stars. It's like watching the universe sketch itself in slow motion. There's something humbling about it, the way math becomes beauty without ever needing permission. And still, humor finds its place even here. You imagine explaining all this to someone who's half asleep. So, you're basically made of atoms cooked in exploding stars, glued together by invisible matter, orbiting an enormous void, and that void is held steady by a rotating bar of galactic traffic. It sounds absurd, and yet it's true. Out here, everything that exists is the result of cooperation between chaos and gravity. You glance back once more toward the center. Sagittarius A times is no longer visible, hidden by layers of dust and distance. But you know it's there, the silent metronome that holds everything in balance. Around it, the galaxy spins like a slow, patient wheel. You think about perspective. From Earth, the Milky Way looks like a ribbon of mist in the night sky. But from here, you see it for what it is, a vast, luminous spiral, shimmering against the black tapestry of intergalactic space. And in the middle of it all is that tiny, invisible heart you've just escaped. The bar beneath you glows faintly red, trailing into the spiral arms like embers caught in a slow wind. The pulsar's ticking fades into the background, replaced by a gentle hum, the collective resonance of billions of stars, each orbiting, each shining, each adding a note to the Milky Way's song. You realize then, you're not drifting through emptiness. You're moving through music. Every orbit, every photon, every ripple of gravity is a frequency. Together, they form a harmony older than time, and somewhere, deep in that song, is the melody of home, the same one that hums through your bones when you look up at the night sky. You're part of that music. You always were. The galaxy breathes. The stars shimmer. The universe hums its lullaby. And you, a dreamer of dust and curiosity, float onward through it all. Halfway between the heart and the horizon, you drift further outward, and the light begins to thin. The crowded stars of the inner bulge fade behind you, replaced by the graceful arcs of the spiral arms. You're no longer inside a storm, you're in the quiet after. Here, the Milky Way spreads wide, its luminous arms stretching like rivers of light winding through an ocean of dark. From this vantage, you can see where the structure begins to take its most familiar shape, the Milky Way's spiral arms, Perseus, Scutum Centaurus, Sagittarius, Norma flow outward like the petals of a cosmic flower. Each one is a nursery of stars, glowing with blues, pinks, and purples, where newborn suns still burn with the heat of their birth. You float over them as if gliding across a vast galactic reef. Clouds of hydrogen gas shimmer with faint crimson light. Star clusters hang like pearls on invisible strings. And every so often, a burst of brightness erupts a supernova, a newborn cluster, a shockwave echoing through millions of years of distance. This is the Milky Way's living edge. It's where the raw material of the cosmos, hydrogen, helium, dust, is continuously recycled into new suns, new planets, new beginnings. Astronomers call the place you're drifting through the galactic disk a flat, thin expanse, about 100,000 light-years wide, but only 1,000 light-years thick. That means the galaxy is so broad and delicate that it's proportionally thinner than a sheet of paper compared to its diameter. And within that fragile plane, everything we know, every star you've ever seen, every world, every nebula, is born and dies. You glide closer to a glowing band of dust that threads between two spiral arms. From afar, it looks dark, like a river of shadow cutting through starlight. But as you approach, it brightens faintly, revealing intricate curls and waves regions, where gravity is slowly collapsing gas into dense knots that will one day ignite as stars. These are stellar nurseries, warm and restless, filled with swirling proto-suns and shimmering dust grains. You drift through one, and for a moment, it's as if you're inside a cosmic womb. Warm, amber light surrounds you. You can see tendrils of gas curling like slow-motion smoke. Somewhere within, a young star pulses faintly, its light scattering across the dust. Around it, a faint disk is forming the seeds of future planets. Each grain in that disk might one day be part of a mountain, or a moon, or the core of some far-off world. You imagine that thousands of light-years from Earth, in some alien future, a being might look up at their night sky and see what we now call home, our galaxy, and feel the same wonder you feel now. You move deeper, feeling the faint warmth of creation against your face. There's a serenity to it, chaos, that makes sense in slow time. Then something catches your attention, a pattern of repeating flashes. At first you think it's another pulsar, but the rhythm is too complex. The pulses are uneven, like Morse code from an unseen hand. It's not a pulsar, it's a fast radio burst, one of the strangest signals known to science. Astronomers have detected them for only a few decades. Millisecond-long explosions of radio energy, brighter than entire galaxies, but lasting less than the blink of an eye. Some repeat, some never return. Their origins are still mysterious, colliding neutron stars, magnetars, extraterrestrial beacons. Here, floating above a spiral arm, you feel the echo of one as it passes. A ripple in the invisible spectrum washes through you, sharp, electric, exhilarating. It's like hearing a thunderclap made of silence. You can't see it, but you know it's there, and just as quickly, it's gone. The galaxy keeps its secrets well. You drift on, past the glowing nurseries and quiet interstellar planes, toward a region dotted with open clusters, groups of stars born from the same cloud, bound together by gravity but slowly drifting apart. Each cluster is a family in motion, and you can feel the faint tug between them. You pass through one such cluster. The Pleiades, a swarm of blue-white stars, wrapped in wisps of dust. They shimmer like a handful of diamonds tossed into the night. From Earth, they're known as the Seven Sisters, but here, up close, you see hundreds of siblings, each radiant, each singing with ultraviolet fire. You slow your drift, letting their glow wash over you. It feels clean, pure, like sunlight after a long winter. These are young stars, only about 100 million years old, mere children by galactic standards. Their light feels like laughter, their warmth like curiosity, and somewhere among them, small disks of dust orbit, forming new worlds. The Pleiades are a promise. The galaxy never stops making stories. Further outward still, you see the faint edge of the galactic disk. The density of stars begins to drop. The light thins into isolation. Here, the arms fade into the stellar halo, a ghostly sphere of ancient stars surrounding the Milky Way like a faint mist. Many of these stars are relics of other galaxies, stripped away by gravity over billions of years, absorbed into the Milky Way's growing body. They are immigrants of the cosmos, remnants of smaller galaxies that were swallowed whole. Their orbits are long, looping paths that take hundreds of millions of years to complete. One of these stars drifts near you now, alone and ancient. Its light is weak, its color red, its surface quiet. You can almost sense its age older than the sun, older than most of the Milky Way itself. It was born when the universe was young and restless. It has seen galaxies collide, watched the arms of the Milky Way twist and settle. It has circled the galactic center perhaps 50 times 50 cosmic years. And it's still here, burning softly against the void. You pause beside it for a moment, feeling the deep calm that only something this old can radiate. There's no rush here, no noise, just endurance, quiet and absolute. If the galactic center was chaos, and the spiral arms were life, then this halo is wisdom. It's the silence after the symphony, the long exhale of everything that came before. You drift outward one last time, watching the Milky Way shrink behind you. From here, you can finally see the whole thing, its swirling arms, its glowing core, its delicate halo of light. It's breathtaking, fragile, infinite, a trillion suns, all woven into a single, turning masterpiece. You realize then that you've spent your entire existence inside this structure, orbiting within it, never once seeing it for what it truly is, a luminous island of time in an ocean of forever. You exhale slowly, and for a moment, everything feels still. You can almost hear the heartbeat of the galaxy fading in the distance. You're not falling asleep. You're falling into the Milky Way itself. And in that drift, between one breath and the next, you become part of its story, another mote of light, circling its endless heart. You drift beyond the halo now, out into the quiet dark that outlines the Milky Way's invisible skeleton. The galaxy grows smaller behind you, a glowing spiral suspended in the cosmic ocean. Here, the darkness feels different, not empty, but textured, as though invisible threads hum softly all around you. Those threads are real. You're gliding through the galactic halo of dark matter, a vast, unseen sphere that extends hundreds of thousands of light years beyond the visible stars. It doesn't glow. It doesn't collide. It simply weighs. Roughly 85% of the Milky Way's mass hides here, shaping everything without revealing itself. You can't see it, but you can feel it. Like the faint pull of a dream, dark matter cradles the galaxy, keeping its arms from flying apart. Without it, the Milky Way wouldn't hold together, it would unravel like smoke. Scientists still argue whether dark matter is made of undiscovered particles, WIMPs, axions, sterile neutrinos, or something even stranger, like hidden dimensions of gravity. You picture it as a gentle fog, coiling through the galactic structure like breath across glass. It doesn't care about light or time, only mass. You drift further into that unseen field. The stars behind you fade into a single soft glow, and for the first time, you see the shape of the Milky Way from the outside. It's beautiful, an intricate whirlpool of light, turning ever so slowly in silence. The spiral arms shimmer faintly in blues and golds, their faint dust lanes curling around a golden core. The black hole, now impossibly distant, lies hidden at the center like a seed inside a flower, and you realize everything that's ever happened in the Milky Way, every supernova, every sunrise, every whispered dream, fits within that swirl. Even you. You turn slightly, and there, faint but immense, another galaxy glows on the horizon. The Andromeda Galaxy, our nearest spiral neighbor, 2.5 million light-years away. Its arms shine like a mirror image of our own, faintly blue and serene. Between you stretches a gulf of near-perfect vacuum, yet gravity is already pulling the two together. One day, about 4 billion years from now, the Milky Way and Andromeda will collide. Their stars will dance and merge, their black holes will spiral inward and fuse, and the two galaxies will become one Milkdromeda, as some astronomers jokingly call it. You imagine watching that slow-motion merger unfold over eons. Stars slingshotting through tidal bridges, nebulae torn apart, and new constellations being born in the chaos. It's not destruction, it's transformation, a galactic embrace. The Milky Way has been doing this, forever devouring smaller galaxies, absorbing their stars into its halo. The Sagittarius dwarf galaxy, the Canis major dwarf, the Magellanic Clouds, each one caught in the same gravitational waltz. The sky above you is littered with faint streams of stolen starlight tidal tails, marking the path of cosmic cannibalism. A quirky tidbit: if our galaxy had a soundtrack, it would hum in a deep B-flat 57 octaves below middle C. That's the frequency of pressure waves rippling through hot gas in galaxy clusters. You'd never hear it, of course, but the idea that the cosmos has a key feels oddly comforting, like the universe is playing its own eternal song. The temperature here, far beyond the stellar disk, is just a few degrees above absolute zero. There's no sound, no light, except the faint glow of the distant Milky Way. But you're not alone. High-energy cosmic rays streak through the dark, particles born from the violent deaths of stars, traveling near light speed across the void. One zips past you, a proton that's been wandering for millions of years. It doesn't slow, doesn't change course, it just keeps going. Like an old traveler who's forgotten why he left home. You let it pass, then look back again at your galaxy. It looks fragile now, almost translucent, a floating island of light adrift in nothing. Yet it's ancient, stable, alive. You can trace the faint glow of its spiral arms and imagine every world within them, the hot blue stars, the golden suns, the lonely planets orbiting in quiet perfection. Somewhere in one of those arms, a small yellow star hosts a pale blue dot. And on that dot, something called you once looked up at the night sky and wondered what was out there. That small wonder is now echoing through the galaxy's edge. Scientists still debate the Milky Way's true shape. Some say it's barred, some say it's warped. Recent data from the Gaia mission shows the disk actually ripples, bending and twisting like a slowly breathing sheet. Even our galaxy seems restless, flexing its luminous spine as it drifts through the cosmic web. The cosmic web, that's what lies even farther out. Giant filaments of dark matter and gas stretch across billions of light years, connecting galaxies like beads on a string. You float toward it now, the Milky Way shrinking behind you until it's just one glimmer among countless others. And that's when the perspective truly hits. Our galaxy is one of trillions. Every patch of sky, no matter how small, hides hundreds of galaxies, each with its own black hole, its own stars, its own version of a U staring back into the dark. You're not at the center of the universe. You're not even at the center of your own galaxy. But somehow, that makes it even more beautiful. You glance back one last time. The Milky Way glows softly, its edges fading into the dark matter mist. It's turning endlessly, a spiral of patience and light. Somewhere deep in that core, Sagittarius A times still spins silently, devouring time itself. Around it, billions of stars continue to rise, shine, and fade. You smile because you've been there. You've wandered through the galactic center, watched the stars collide, skimmed the photon sphere, and now you're here, outside it all, watching from infinity. The galaxy feels almost alive. Maybe it is. Maybe every spiral arm is a heartbeat, every black hole a pupil, every solar system a fleeting thought. You drift in that possibility, suspended between awe and peace. And then you start to slow. Not because gravity pulls you, but because it's time. The journey has stretched far enough. The edges of awareness blur, and the hum of the cosmos softens into a low, steady rhythm. Your pulse syncs with it. It's not silence anymore. It's serenity. The galaxy is now a distant whirlpool of silver, shrinking into a shimmer among the endless dots. You float farther still, beyond the influence of its gravity, beyond its familiar spiral arms and glowing core. Here, the dark stretches forever, unbroken and patient. There's no up or down anymore, only the quiet geometry of existence. You move slowly, though speed has no meaning out here. Every direction looks the same. Every speck of light, another universe's dream. The Milky Way drifts behind you like a lantern fading into mist. You think about everything you've seen. The chaos of the galactic center, the maelstrom of Sagittarius A*, the tidal ribbons of stars, the luminous nurseries where new suns are born. You've traced the life cycle of an entire galaxy in a single night's drift. It's strange, though the farther you go, the more peaceful it becomes. The cosmic noise fades, the light softens. You begin to feel as though the universe is breathing with you. Slow, steady, infinite. A mainstream fact drifts through your mind. The Milky Way is just one node in a vast supercluster called Laniakea. a name that means immeasurable heaven. It spans over 500 million light-years and contains hundreds of thousands of galaxies. Gravity binds them together in an invisible flow, like rivers converging toward deeper cosmic valleys. You're floating along one of those currents now, drifting in the same grand tide that carries every galaxy toward the great attractor, a mysterious region of mass and motion, whose pull shapes the destinies of countless worlds. Scientists still argue whether the great attractor is a cluster, a void, or something stranger, perhaps a distortion in space-time itself. Whatever it is, it hums in the distance like a cosmic metronome, guiding everything in a silent, slow-motion dance. And yet, even this vastness feels intimate, because the same physics that shapes galaxies shapes you. Gravity binds the stars, and it also binds your heartbeat. The forces that spin black holes are the same that keep your feet on Earth. You are, quite literally, built from the same equations that sculpt the Milky Way. A quirky tidbit floats up from memory. If your eyes could see microwave light, the night sky would glow faintly everywhere, the afterglow of the Big Bang, stretched thin across the entire universe. You are never really in darkness. Even the void has a memory of light. You look down, or what your mind interprets as down, and see nothing but the velvet texture of infinity. Somewhere, billions of light-years away, other galaxies are flickering, merging, dying, being reborn. It's like watching sparks in an endless bonfire, each flame telling a story older than language. And in all that immensity, you feel something simple, calm. You've left the noise behind. The gravitational storms, the bursts of radiation, the swarming clusters, they're all distant now. What remains is the heartbeat of space itself, a low, unending vibration. Maybe this is what the universe sounds like when it sleeps. You let yourself drift, weightless and aware. And for the first time, you sense not the size of the cosmos, but its stillness. You've spent the whole journey seeking the center of the Milky Way, and somehow, you've ended up finding your own. You close your eyes, though they were never really open, and you feel it, the echo of the galaxy inside you, the swirl of atoms that were once stardust, the quiet gravity that keeps you grounded, the soft hum of being alive in a universe that knows no edge. Everything you've seen, the chaos, the beauty, the impossible distances, was never out there. It was always within you. And so, the stars fade. The black hole stops whispering. The spiral arms dissolve into a gentle, cosmic fog. All that remains is the rhythm of your breath, the warmth of invisible light, the faint memory of motion. The Milky Way continues to turn, slow and eternal. But you are still now. You are part of its quiet geometry. You are the space between stars. The hum grows softer. Time stretches thin. Every heartbeat feels like a century. Every breath like the orbit of a planet. The universe doesn't end. It only exhales. You let it carry you. The darkness folds around you like silk, and as you finally drift into sleep, you realize you're not falling away from the galaxy at all. You're falling with it, turning in the same timeless spiral forever, part of its endless dream. Now the voice softens, words lengthening like starlight stretched across time. You're far from the black hole now, far from the heat and gravity, resting in the gentle outer waves of silence. The Milky Way, turns slowly behind your closed eyes, a river of light looping through eternity. You feel its motion, faint as a heartbeat beneath the pillow of the universe. Every pulse is a reminder that even in stillness, everything moves. The cold between galaxies no longer feels lonely. It feels fulfilled with the hum of unseen particles, the memory of every photon that ever was. You are wrapped in it, safe within the same fabric that holds galaxies together. Breathe in, and the galaxy breathes with you. Breathe out, and the stars drift a little farther. The universe doesn't ask you to understand it. It just asks you to rest inside it, to let gravity and light do their ancient dance, while you drift softly, quietly, endlessly. You are small, yes, but not insignificant. You are a pattern made of stars. So let go of thought now. Let the spinning fade. The Milky Way will keep turning whether you watch or dream. Its black heart will whisper. Its arms will shimmer. And you, tiny, beautiful, you will sleep among the stars, perfectly at peace. Good night, dreamer.